Hello world and welcome to another episode of FooBar. In today's episode we are going to talk about chaos engineering in serverless applications. If you want to know more about serverless, cloud computing or software engineer practices in general, subscribe to my channel in the red button below. I post a video every Tuesday. So let's get started! This video is sponsored by Thundra. Thundra is a serverless observability platform helping developers debugging, testing, and troubleshooting their serverless applications with no code change and zero overhead. You can see their demo environment by clicking the link in the description box. Thank you very much, Thundra, for sponsoring this video. This is the final episode in our series of hunting errors in serverless applications, but that doesn't mean that it's the last episode. I can make a second season of this playlist if you have a lot of questions and topics you want me to cover, so don't forget to tell me in the comments or in Twitter or wherever what you want to see next. So in this episode we will be talking about chaos engineering, what it is and how to get started with it. Sometimes the chaos engineer sounds very daunting word and something very complicated, something like Netflix has done, but how I can do it as just a small company or small developer in a team, but it's not that hard and it's something that it will bring a lot of value to you. So let's get to it. So let's start by asking, what is chaos engineering? Chaos engineering is defined as the discipline of experimenting on a distributed system in order to build confidence in the system's capability to withstand turbulent conditions in production. For injecting chaos into our application, we are going to use Thundra. In the previous video of this series, we configured it and we learned how to debug live applications with it. I'll leave you the link for this video in the description box. In this video, we are going to use the span listeners and filters. We are going to work with spans that are a concept from open tracing. A span is an individual unit of work done in our functions. Those can be created manually or automatically. We will be working with span filters, and span filters contains the parameters that we want to filter out, so we can trigger the errors in those specific resources. If we want to trigger an error when we put something in a Dynamo table, or when we read something in the Dynamo table, we need to set that Dynamo as the class name. So we need to put in the class name the name of the managed resource that we want to make the error to happen. In this case, it's AWS Dynamo. Then we need to specify the name of the resource so the error can happen in a specific table if we want that to happen. In this case, it will be table name, but it can be any name that your table has. And if you want to know, like, for example, if you want to only apply the error when we are writing or reading, then you need to put that in the extra information in the tags. Then we have span listeners. Span listeners can be used to create latency or to inject errors into our system without changing the code. The span listeners will have the parameters for that error. Sometimes the message, the error type, if we want to add some latency, what is the amount of latency, and things like that. Then we have the filtering span listener that will be referencing the error or latency injector and the span filter. So then these two things combine and the magic will happen. I will show you exactly all this in action in the video. So what we are going to do in this video, we won't go into the details of chaos engineering. I don't have time to put that in this video, but if you would like to have a more theoretical video about this subject, let me know in the comments box below and I will be happy to create a video that is a little bit more theoretical and going into the basics of chaos engineering. However, we are going to get hands-on and we are going to see how to get some experiments working in our serverless application. We will use the same application we used in the previous video using Thundra, and there we are going to create experiments. We will create two experiments, one experiment that will add an error in a managed service like Dynamo, and another one that will aid latency in the response of SQS. So let's go to the code. So we are going to start by just cloning this project in our computer, and I will put the name SLS Chaos, and you can put any name you want, and then I will open it in Visual Studio Code and we can just do a small change to our serverless YAML to get started. So the first thing we want to do is to change the service name. So I will call it SLS Chaos Eng, and then I will change the name of the table and in the queue, so there is no conflicts if those already exist in my account. And after that, then I'm ready to start working. I will configure Thundra. I have done this step by step in the previous video. Go and check it out if you want to know how to do it in more detail. Now I'm going just to do it fast, but you need a Thundra account and follow the instructions there. So the first thing I'm going to create is a new project so I can get a new API key for my application. I will call it SLS Chaos Inch, and I will copy that that key into my parameter store, and I will just reference it from my serverless YAML. If you don't know how to use the parameter store, I leave you a link in the description box about that. Then I'm just going to require Thundra in my handler.js before my AWS requirements, and then I'm going to put the reference to the environmental variable that we just created, the Thundra key, and then I will wrap all my functions using Thundra. So this we have done in the previous video, exactly the same. And don't forget to add the layer. If you're watching this video in the future, don't forget to go and check in the documentation the version of the layer that you're going to use. If you want to know more about layers, there is a video about that as well, so I'll leave that in the description box. But basically we are just having all the libraries that Thundra requires in this layer, so we don't need to import it in our Node project. We are just adding this layer to all our functions, and then we are ready to start working on our chaos experiments. So to know more about the chaos, go to documentation, inject chaos to your AWS Lambda functions, and there you can read about span listeners, span filters, and all that stuff. But I will show you how to implement these two different errors in the application. I will show you how to inject an error when, I don't know, reading something from Dynamo, and then I will show you how to inject some latency between your function and SQS. But all this is explained in the documentation, and you can go and check it out. So the first thing we want to do is to inject an error when we are going to read from the database, and when we are getting the order, if it's ready or not. There I want to inject an error. So basically I want to return that Dynamo is down. So we need to follow some steps in order for this to happen, and we need to do all this in the top of our file before the AWS require. First thing we are going to do is to create a Thundra wrapper. That's the one that we are going to use in all wrapping all our handlers, and there we will reference the API key. The next thing we want to do is to import some classes. These are just importing the spans and the filters to our project, and then we are going to create the first filter. So here we are going to put all the information we want to have in order to filter where the errors to happen. The first thing we want to do is to happen in Dynamo, so we have to put in the class name AWS Dynamo. The operation name is the name of the table because we only want it to happen in this particular table. If you want to happen in all the Dynamo calls, just don't put this on. And then if you want it to happen when you read, you just put operation type read, and if not, write, or you leave this out and it will happen always. You can find more about the tags and the class names in your Thundra. If you go to tags, you will see all these things in more detail. I will show you when we deploy this how it looks. The next thing we are going to do is to add this filter to the span filter, and then we are going to create our error injector config. There we are going to define the error type, the error message, and when we want to inject this, and then we just configure that in our span listener, and then we create the filtering span listener that will link the two things together, the error injector and the filter. And after that we are ready to rock. We just put that span in our Thundra, and then it will happen whenever a Dynamo call to that table in a read property happens. So now we can deploy and we can see how this works. So I will speed up the deployment and we are going to see it in Postman. So now in Postman, I will just create a new order. So then I can get this order and I will just make that call. And then I will just get that order from the database. And this tells me that there was an error on processing the order. So we can go to Thundra and see the last invoked functions, and there we can see that there was one error, and it's an HTTP error. And if we go, we can see that there is an error in Dynamo, and there we can see in the response that there was an error processing the order. And if we go to the tags, there we can see that the error was a Dynamo error, in the message was Dynamo crash, and we can see there, if you look carefully, you can see the class name and the operation type and things like that you just put in the when you were creating this filter. Then we can go and check the trace, and you will see that it's showing you the trace of where the error happened. So this can help also the visibility of the error. So now we have that error. The next thing we can do is we can add some latency, and it's as simple as adding that error. So we are just going to modify these things that we just wrote to add some latency when we are sending a message into SQS. When we are making an order, we are putting a message to SQS, and there I want to add some latency. So the thing we need to do is to just replace that error injector with a latency injector, and then change the filter. We are going to change the name to something like AWS SQS. Then we are going to change the operation type into the queue name. So when we are putting something in that queue, then it just fails. And then I'm going to leave the operation type to write, because we are writing in the queue. The next thing we want to do is to configure the error injector. Now is a latency injector, and we want to add a delay of 8,000, and that means that the latency will be higher than the life of the lambda. Lambdas are configured in Serverless Framework to live for 6 seconds, so this latency will be higher than that, so then the whole thing will just fail. And then we change things in the filtering span, and then we are ready just to deploy and see it in action. So I will speed this up, and then we can go and check in Postman what is going on. So now we can go and create a new order, and that should put the message in the queue with the delay, and it should not happen, and we should get an error back. So we can see that the response time is very high, and there was some error. So now we can check our functions, and we can see that there was an error in this one, time at error. And if we open it, we can see there was an error in Lambda. And if we go to the response, there was an error there. And then if we go to the queue, we can see that there you can see the class name again and the operation name as well. So that's pretty nice. And then if we open the trace, you can see the Lambda that is with the red things around, because there was some error. So now let's do one more thing. I will put everything as it was before, just to use remove all these filter spans and everything that we have created in the handler. I will just require Thundra in a normal way and wrap my functions around as we were doing before. And I will show you a good way, an easy way to add these filters. So we are going to our serverless YAML, and we are going to add a new environmental variable called Thundra agent lambda trace span filter. You can find the description of this in the documentation of Thundra, and there you need to write something like this. Basically, it's filtering span listener, and then the type of listener you want, in this case, is a latency injector with a delay of 8,000, and then you will add as many filters as you want. You need to always start with the word filter, and then you can put filter 1 is the AWS SQS, because it's the class name. The operation name is the name of the queue, and then the operation, the tag operation type is a write. And with these 4 lines, you can write exactly the same that we wrote with, I don't know, 13 lines of code. So this is really cool, and you can just disable this easier than just writing all this long text in your code, because it's an environmental variable. You can set it to something else in deploying time, so it's very easy. And in documentation, you will find how to configure everything from the environmental variables. So basically, then you can deploy, you configure the environmental variable, you deploy, and then you can test in Postman, and you will see that you will see exactly the same error that we saw with SQS and the latency. So that's very, very good. As always, you can find all this code in the GitHub, and the link is in the description box below. This was the video for today. I hope you like it. If you did, give a big thumbs up. And this is the last episode in this series, so please don't forget to tell me what is you want to see next. I'm really happy I'm making content that you want to watch, so please let me know what you want to see. And around here, as always, there are other videos from my channel for you to watch, so go ahead and click, and if not, I see you in the next episode of FooBar. Ciao, ciao!